I'd like to introduce Dan White, 80CQ. His talk is titled From Ad Hoc to Automated Data Collection in Linux.
Thank you, Steve. I'm happy to be here. My day job is a electrical and computer engineering professor at Valparaiso University, and there I call my lab the Wireless Research and Electronic Discovery Lab. And if you have an academic lab, you always have to have a 3-level deep lame acronym. So that's what we came up with. All right, so there's a lot of ad hoc in here, and if you're looking for lots and lots of automation, know that it's a process. Okay? All right, so I have a background from back in the day, say a previous life, from live sound, live in studio and such. There's three rules of live sound. Make noise is rule number 1. Rule number 2 is keep making noise. If anybody turns around to look at the sound guy, just don't go back to work. And rule number 3 is make it sound good. It's only until we get number 3 that we go from there. Reliability is the thing. All right, so we'll use that as the prompt for how this is going to work out today. So if we have data collection, we're going to talk about recording information. I use 3x5 note cards because they never run out of batteries, and that's a great way to collect data. We got to keep collecting data. Don't lose it. And then do something about that. All right? So on the collect data side, before we get to that, a little background of where I'm coming from, or from the setup that I'm talking about, is, I skipped ahead. So what are we going to collect? Yeah, but I don't know what this is. I don't know what kind of data I need to collect next week. I have some general ideas, but if I knew exactly, I'd have the infrastructure, it'd be all automated, it'd be in a Docker container, and we'd be done, okay? But I don't know, and that's why I like my job. All right, so the first part, we need some hardware for this. This is a remodel in my lab over the summer. 1,800 pounds of cinder block that goes up to the roof. I won't say exactly how it got up there, but one day it was on the ground, next day it was on the top. Right, and the few times that once a year I take a selfie, it's on the roof of a university building. So we have lots of hardware on the roof, and one thing that struck me was, we do all this wireless stuff, and I've got 3,000 feet of cable in my lab. So my budget could be a LMR 600 because I had to pay someone else to pull it, and I wasn't going to pull hardline. Cat 6 because once you put something in, we're not pulling this again. So we can do 10 gig Ethernet and power over Ethernet. The new, I don't think it's quite ratified yet for the 80 or 100 watts of power, and then just a bunch of multi-conductor cables for who knows what. Like I said, I don't know what we're doing next week, but we need to have something to support this. So once it's all up there, we take a nice, beautiful shot, get our chapel on campus on here. So these are a pair of M-squared antennas that have been sitting in my lab for ever since the last time I talked at DCC, which was way back in 2016. So we pushed it through the committee process, and it magically went up to the roof. Like I said, I won't say how it went from the ground to the top. Over on the right side, this is another view from the other end of the roof. We've got a mast in the middle, HF fan, 5-band dipole for who knows what, perhaps a big listening to whisper or space weather things. And then up here we have just horizontal fiberglass booms for mounting who knows what. And the who knows what is who knows what? I don't know yet. So antennas, antenna testing and such. All of that stuff comes down to a patch bay, a network switch, and all of the network in the lab, just kind of out of necessity, is not only has a gateway connection to the campus network, because that's how we can make peace with campus IT. And then I have the only non-illegal Wi-Fi access point on campus. Engineering IT guy says, if they give you trouble, tell them that I said it's okay. And then in other hardware, of course, and then just stacks and stacks of Raspberry Pis, and I just picked up a number 4. The server farm is just a bunch of desktop PCs with no displays. All right, what can we do with this? One thing that you can do in about 5 minutes if you have a Raspberry Pi and an RTL SDR dongle is listen to ADS-B broadcast from aircraft. And it was up and running in about the same amount of time as it took to flash the SD card. Local traffic, Valparaiso is near Chicago. We're just south of there, and we get plenty of air traffic. It's really fun to turn on the weather radar overlay and watch the aircraft route around there. Okay, so next up, that was really this summer. These are just some random notes I was just shoving in a Google Doc, just getting things on the roof, putting stuff online. It was really exciting, and so we put some things on the roof, make some observations. Basically, a lot of our antennas are part of SatNogs. You'll hear about that on Sunday. So making some stuff, making some notes. I don't have any scans in my 3x5 cards, but you couldn't read them anyway. So everything's good, okay? So here's continuing on. This is literally the next line in my notes. So if you can see from the first thing, I was back on the roof 3 times that day, and I looked around. You look around on our campus, and I looked this direction and looked up because I was looking at the antennas. Right when you're on the road, it was great. I look and I realized that our campus FM station was just beautiful direct line of sight. So on. It's a 36-watt station, and but 200 meters away. So that explained a lot why Fox was relaying our campus radio station. I just thought that was both odd and illegal. It was just intermodulation, so put some filters on there. Need to rerun the noise script, and let's just say the whole summer was a lot of fun, and it continues to be a lot of fun. This is, I won't call this the end result, but this is kind of a current status. So we're going to get, this is the end, and we're going to get to how we get these sort of displays. A couple SatNog stations running, hooked up to different antennas for an antenna testing experiment my students are working on. And now you can just look at this dashboard and see that one of these is not working so well. It's not so healthy. So the one on the bottom right, its file system was steadily filling up. This dashboard now allowed me to deal with the situation before I had to climb up to the roof again. Because when it died in that situation, it would just become unreachable, even though it was an Ethernet connection, hardwired connection to the roof. So that's really nice. Even better is to just get an email when things are not going well. Then I don't have to check it all of the time. At home you just refresh and look at that. It doesn't go so well when you're out feeding your chickens. All right, so this is the status that we're at right now. How do we do this? First of all, we're going to collect some data. One of the technologies that I've used for collecting this sort of data, see, I didn't know that I needed to monitor the disk space on my Raspberry Pis. Everything was working okay. It records the information, it sits there, another task just loads it 5 minutes later. It never fills up, right? Until it doesn't work. All right, so we need to collect some data. At this time it was CPU temperatures and such. Technology that I was using, or am using, is called MQTT. It is used a lot as kind of an under protocol, kind of under the, in the infrastructure for Internet of Things, a way of communicating between devices, many devices, and such. It says publish, subscribe, so I would publish some information to a central server under what they call a topic, or a tag, an address, And then anyone that also connects to that server or any other machine can subscribe to that topic. If I send some information to that topic, someone subscribed to it, the server just sends around and sends it back out. It's not broadcast, but any number can push and pull to these topic names. MAC addresses make handy unique identifiers for this. Mosquito is the open source implementation of this. It's very easy to set up. You can run this on a Raspberry Pi. I just happen to have it on a server, a private server that I've had running for years and years. One, because it's outside of the campus network, and I get to control the firewall. All right, so that's been very handy. It's a lower level thing. Once you set your topic, you send data to this. The data is just a bag of bytes according to MQTT. You can this can be binary information or whatever you would like. Some other utilities that allow you to connect to this and just look at this. This tool, MQTT Explorer, is kind of nice for debugging. And this is not an animation, but it will show you packets as they arrive and what topics that we're hearing at any given moment. This is not intended really to be readable, but Wired Lab here, PyWire 1, SatNogs 1, they were in the last minute that I had this up and took the screenshot, had just sent time-stamped CPU temperature and status of the file systems and such. Also down here is RTL 433. Just as a side note, that's a nice utility that hooks up to your RTL SDR dongle, and it receives ISM band transmissions and decodes them. I think it's pushing 100 or several hundred things like personal weather stations. You get the temperature and humidity transmitters with the LCD display. You don't need the LCD display. You can just receive it off of the air. This is broadcast. We set that up. Gem 163 happened to be broadcasting. That's one of the rooms in our building. So after contractors came in and fixed the air conditioning, the department decided we needed to monitor the temperature and humidity in that room because 85 does not mean the air conditioning is working. All right, so now we have data to go back and say, well, we know exactly when it failed. Please come back and fix it. All right, so that's a nice utility, really not associated with the amateur radio and such, just a receive side. Another node down here, the note says MQTT is kind of nice. Anything that can run a network stack, which nowadays is a ton of little equipment. So the ESP8266, this is a microcontroller. It's a 2-core microcontroller, I think 60 megahertz or so clock. You can program these with through the Arduino IDE, so it's really easy to get started. But they do Wi-Fi, and if they do Wi-Fi, you can do anything you want, including use this as a publisher sending data out. So one of those nodes, an ESP32, which includes Bluetooth, is just sniffing Bluetooth LE low energy packets in the vicinity of my lab. And it makes for an interesting data privacy discussion with students because they said, you can do that? And it's like, your phone is blasting out unique identifiers all day long. This is near trivial. Look how trivial it is. Professor White can even set it up. Okay. If just log into MQTT server or just subscribe to everything, what we do is you can come in. MQTT itself doesn't timestamp packets that arrive, but if you just subscribe to everything and timestamp everything that comes in, you get timestamps. That's really even Mosquito says, that's not the way to do it. But you know what? I don't have a bajillion packets per second in my network. All right, so these two examples are examples of topics that show up in MQTT. They use slashes to create a hierarchy, like a file system hierarchy. You can set it up as whatever you want, and this is just the MAC address of my Bluetooth receiver. Everything after that is just a bag of bytes. I've settled on using JSON as a thing that I can just read over the wire. and then computers can interpret that as well. We're going out of order because this is ad hoc. What are we going to do with this data once we get it? Because when you decide that you want to collect the data, you have a purpose in mind for this already. So one really easy way to start, and is what I'm doing, is software that's it's called Node-RED, clearly. They can never change their color scheme after this. That'd be note to self, right? Never name your project after a color because you can't do any graphic redesigns. So flow-based programming for the Internet of Things. You can install Node-RED. 2 more clicks will get you to a copy-paste command line to install this on your Raspberry Pi. I have this on a desktop machine, a headless desktop machine, just so I don't run out of horsepower, because all of my Raspberry Pis are doing sat-nodes. So Node-RED flow-based programming, what does that look like? So this is the editor. All of this runs in a web browser. So the server runs on a Raspberry Pi, but it just sets up a web browser on a certain port. You log into that as long as you can reach that on your network. And then you have various sorts of inputs. This is showing I'm subscribing to my MQTT server, subscribing to a certain topic. They have this neat thing called wildcard topics, where you can subscribe to an entire subtree of things. You don't have to know your name exactly. It does encourage you to have at least some thought of how you want to structure your names. And then every time a packet comes in from MQTT or that gets published, as soon as it's published, this is a subscriber. It's going to get a packet. It's just going to come in a real-time-ish, just network and server delays. I have a watchdog on this. This watchdog will time out after, I think it was 5 minutes, because I want to know when this particular machine quits sending packets. This is for that RTL 33 receiver, the ISM band, listening, and sometimes it would just quit. And I would want to know when it quits. We get to the next level after that is here coming up. So when it quits, I want it to send me an email. This format email thing is literally 4 lines of JavaScript. You don't really have to know JavaScript to write 4 lines of it. You can just look at plenty of examples. Look at 3 examples, and you can figure it out, right? That's the nice thing. And then sends me an email. After that, it sends another thing. This flow, the data just gets split out over here. This green box at the top is just a debug node. It'll show up and show you those packets as they arrive in a separate sub-window off to the side. A little switch statement, but this is you could call it a filter. Map the RF channel number that's in the data packet to the room that I have the sensor installed in, so I know what I'm looking at and don't have to remember those things. And then here's the cool part, you can send it to a chart. And that's how we got the plots on the other page. This is the programming side. You flip over to the other side and you can get that dashboard of plots. You don't really have to set up too much. If you don't like the style and the theming, then you can change it, but you've got other things to do, right? So you're just really happy that these are set up like that. Let's see, this is telemetry from Raspberry Pis. The PiAware one has a power over Ethernet shield on it, and it has a 2-level fan. I didn't know it had a 2-level fan until it started going even faster than it was, and I said, whoa, this is a 2-level fan. All right, so we can plot that, and I wanted to know this PiAware stuff. Most of these Pis, they live in weather-resistant boxes on the roof. And, it's in the sun. It was over the summer. Do these get too hot? Sure, the one with the fan is probably going to be fine, and it has been. But the other Raspberry Pis, they just have heat sinks. They're totally passive, but the boxes are basically sealed up. Are they going to get too hot? I don't know. And that's my favorite phrase. Somebody asks me a question. What do you think? Do they get too hot? I don't know. Let's try it out. This is I don't know what data I need to measure until we have a question that we're trying to answer. All right. Here's one thing that I learned here. If our temporary file system is too full, it sends an email. Okay? Except the telemetry comes every 10 seconds. It took me about 3 minutes to figure out that this was a bad idea, that I need to learn how to do a rate limiter in Node-RED. So we call this just-in-time learning. So we figured out how to make a rate limiter in there. That was amazing. I flipped over to email because I shut off. I don't have notifications for email because that would be insane. Yeah, and I had 5 pages of the file system was too full. All right, so that's Node-RED. We flip over. This is just what the dashboard looks like now that you see how the data comes in. You can see on PyWire 1, we have the fan is cycling on and off, and then during the middle of the day, it bumps up to full speed. The temperature, never went above 58 C or so. SatNogs 1, this one is very even. This one, it has no heat sink, but that's not the one on the roof. It's sitting in the equipment rack. So even when it's working full time, doing lots of SatNogs observations, I've never really seen any temperatures above 75 or so. The chip limit is 85 before operating system starts to throttle things back. All right, we can skip that. So it's just more data and such. You see that there's tabs up here. So this is Raspberry Pi monitoring, other things. This gem and fights environment. Those are the room temperatures. Other plots that we can look at. All right. So next up is don't lose the data. Yeah, because if you lose it, we've all done this before. And did I say that this is an ad hoc talk? Yeah, this part is not automated. So the data that's important to me does live in 3 different disks in 3 different, at least counties, but it's not automated and it's manual and it's getting old. So it's one of the next things that I'm going to automate. Lots of ways to do that, but that's where we're at now. All right, so MQTT, it's kind of a hot thing. It's an underlying technology, so you don't hear about it as a top-line tech news item, but the Internet of Things, it's very popular. Node-RED is pretty cool, right? You do all of the working in a web browser, which is really nice. You can do this on, you don't have to log in, you don't need a display on your Raspberry Pi. That's really nice. But that's just a little fancy, right? You know that the Raspberry Pis, it's a Linux system or a Debian-based system. You just you SSH into this thing and you get your work done. Who needs a display, right? We've been getting work done long before monitors existed. Well, something like that. All right. So if you want to do that, there are plenty of tools in the Linux ecosystem. So if you want to go Graybeard style. So I was in Korea at a conference, and it was like during the filming, we didn't find out later that I was like in Seoul, like when they filmed it Gangnam Style, and then the video comes out, and okay. I was like, I just walked over there. All right, that was a long time ago. It makes me feel old. All right, so there's lots of command line utilities for Linux, and there are many of this command line stuff that we can talk about. At the risk of getting this to be a bash tutorial or a survey of all the cool stuff that you can do at the command line on Linux, this is where my talk is getting short. I wanted to show you these things, especially MQTT and Node-RED. There are other technologies that we use for collecting data and such. The SatNogs network does other things. Grafana is a nice is how we get the dashboards in SatNogs, but it just requires some more infrastructure than I can handle for ad hoc stuff. All right, so we're going to use some shell scripts to get some information. The main command here is just, I'm just asking the kernel what the CPU temperature is. You find these out, do some shell scripting so we get this. Hopefully you structure your scripts nicely. I'm going to highlight this. These are options, at least for Bash, that allow you to shut things down if you have a pipe and one command exits early and the other command is still okay. It's okay with not receiving input. The pipe stays up and the script still operates, but it's not working. So I want this thing to fail because you remember that email, like send me an email because the watchdog thing? It would send me an email, but I would have to like force quit the script, and that was no fun looking for process IDs for which one to kill. All right, so we get the scripts to use the information, and this is where where MQTT comes in. So it's highlighted here. If you're in the back, you can't read this, but really, I'm just sleeping every, I think this is 10 seconds or so, reading the CPU fan, if there is a fan. The if statement came in after the script failed the first time. I installed the script on a Raspberry Pi that didn't have a fan. I'm an electrical and computer engineering professor. I didn't say I was a professional. So I'm in the presence of many people that have built these systems and do this for your day job. So if I say TCP, it's just because I've heard about it. And I know how to follow tutorials really quickly. Faster than my students, and then they think I'm okay. All right, so at the very end, all of this is a line, every line of text, we barf out a line of text out of the script, send this to Mosquito. Remember, Mosquito is the MQTT software. So right from the command line, you can publish messages to an MQTT server. So a few minutes ago, or this morning, I realized that I had my password on the screen, and I said that was a bad idea. All right, so if you want to attempt to connect to mqtt.agnd.net, you might find all the flaws in my security system. All right, so then down here we have topic, just a string here, so I can write this script and put this on any Raspberry Pi as long as I have a unique host name. Which is usually a good idea. All right, so this is how we get information in. But I've alluded to this a few times. We need to keep these scripts up. I want to automate this, and I don't want to babysit these scripts. So I'll go back 2 slides. That's where I learned about really setting non-default conditions here. I want the script to exit when there's anything that goes wrong. If my network connection goes down, which was often, if we bump something, or if who knows what, right? I just want this script to fail. Because if this script can fail, I can detect with many Linux utilities that just say, hey, keep this service running. If it stops in an error condition, or if it just stops for any reason, it's a configuration item, just restart it. That's really nice. All right, so there's a tool that can do this. There's other tools that can do this, but I learned about systemd because that's what's already installed and running in your Raspberry Pi that you have going. So I have no comments about all the other systems. I've used them, but I don't want to be an expert in everything and roll my own. All right, so systemd, you can run services. What I've learned and what I would like you to know is that you can actually write your own services to do some of this automation for you. The other init systems, they did the same tasks. So if we look at this little file, so thermal MQTT service, this is the one that's my Raspberry Pi, CPU temperature, and fan state and such. I want to keep this script running. If it fails, I just want to restart it. So this is all that's needed. You put this configuration into this file here, enable the service and get it going, and then it just works. And the best part is, especially when you're doing ad hoc things, is you reboot the machine and you forgot that you put something in the background. this machine had been running for 3 weeks before you reboot it. So now you've come to rely on this data coming in or the service being up, except you forgot that you just fired this off as like this horrendous one-liner. You put an ampersand at the end, and then you forgot about it. And of course, this was running in RAM, so when the Raspberry Pi reboots, you don't even have bash history to remember what you did. So I prefer to learn things in the most memorable way possible, which unfortunately involves pain. All right, so that's what we have here. These are services, once we understand what we're doing, I want to bring these up. The systemd stuff, once you install the service, you have to remember to enable the service, not just start it. If you start it, it runs and it works fine until you reboot because you never enabled it. See, I learned lots of things, right? Yeah, I know. We learn through pain all the time. It's just effective. So I have 4 students here with me. 3 of them successfully passed after a time or 2. My electronics course that I teach for juniors, and Trieste is going to be doing that next year. And they know that I truly believe that learning through pain is the most effective way to learn things. So I love you, students, but this is actually intentional. I love you so much that this is going to hurt. And then you'll never forget about it, right? So if you if you say that semiconductor that we use all the time called silicon, if you say silicone in my presence, you will have cause to never forget again. So I have a traffic cone that some seniors gave a couple years ago, showed up at my office, like the office door, okay? Because I'm like, okay, you can say silicon, silicon, that's fine. Silicone is a polymer, okay? It's just different. So there was a traffic cone, and I don't have a picture. I should get a picture. And it said SI on it, and then had googly eyes and the whole thing. And I'm just like, after 4 years at Valpo, 8 semesters, at the end of that last semester, seniors just break or something. They just go, I don't know what happens. Then they leave. Then they graduate. We're all sad. And then I'm like, okay, yeah. What is this? It's silicone. Okay. All right. So if we're not up to this sort of thing, if this sort of service, I know how my script is going to work. That's going to work for this. Oh, before I forget, I want to point out that this wanted by, where else is it? Wanted by. This is multi-user target. This, if you remember, this MQTT is trying to use a network right away. This is probably not the best dependency to add into systemd. You want to say, please don't start this service until it's not pointless to do so, because this needs a network functioning. Yep. So that tab is open in my browser, and it's like a to-do list of what to do. So there's lots we can learn about this. Some of these systems can just order things. If we learn about them, make them formalize how we have these are things that we want to do set up. There's so many tools available to do this that usually there's a match for what you want to do. You might have to learn something in the middle, but sometimes it gets a little fuzzy whether we're learning something or you just copy-pasted it. All right, so if you're still doing ad hoc stuff, you want to fire off a couple things, there's this really cool utility called @, which is also very difficult to Google for if you're trying to find documentation, if the man page is just not sufficient for you. All right, so it doesn't come in Raspbian by default, which is annoying, which when you install a new one and all your scripts assume that your environment's there, you have to install this. All right, so you can say at 5:30 p.m., kind of natural language, and then as at 5:30 p.m., as if you type this into sh shell, okay, not bash, so it even throws a warning and reminds you that the shell is a little different, so watch out. You can run a script, and it'll just happen. And it happens once, happens at that time, and it's set up that if you reboot or power down, if you're alive at that time, it will run. It won't queue up or so, but it will actually survive a reboot. I've never tested that, but it doesn't. All right, so if you want to automate, if you want to do this at 5:30 p.m. every day, this gets really old really quick. Okay, so there's a nice utility called cron. It's like ancient, and sometimes old is fine. Old is fine. It what?
It doesn't precede Unix.
It does not precede Unix. It's almost a chicken and egg thing, right? Okay, so if you want to edit this as a user, it's cron-tab-e. Please don't try to edit these files by yourself. Don't ask how I know. It doesn't go well, right? So anything that I know, there is a pain and a story associated with it. Many of those stories are boring, so that's why we have our pictures here. All right, so there are so many other tools. I know Corey does this as his day job. He's just like, there's so many other ways to do this, Dan, that are like so much better. And if you know of better ways, I'm all ears. But if you've not heard of these things before, these will make your life easier, and then you can automate some of the tedious things and do the cool things like playing with digital communications, and that's the best part. So thank you for paying attention. We have, I say there's scripts at my lab's GitHub page. The scripts that I showed you are not in fact up there, but you're totally welcome to annoy me until I put them up there. There's no reason I don't. Remember, this is an ad hoc sort of thing. Yeah, all right. Thank you. Valpo Wired Lab is my lab's Twitter account, and Wide Audio is me. Thanks. Do you have questions?
Questions?
I can give you one extra shell variable that I use all the time.
Wait for the.
No answer. Oh, I was so. I mean, it seems like we have some people fairly knowledgeable here about Bash programming. One thing I use in Bash scripts all the time is to set the no unset option. And which means that if you reference a variable that has not been defined, normally it just becomes blank.
Yeah.
And it's an undefined, it becomes a blank. And you fix all your typos right away, because
exactly.
your shell script will die. So, what's that? Yeah.
Yes, exactly. Thank you.
Any other questions? Well, thank you very much, Dan.
Thank you.